Hello everyone, welcome to Pre-Algebra with Miss Betsy. Today we're going to be introducing negative numbers, which are included in the set of integers. We're going to be in Chapter 4, the first section on page 111. I'm using as my text Pre-Algebra for Christian Schools using the first edition. Once again, doesn't matter what book you're using, even if you even have a book, but we'll be talking about concepts that are common to every single pre-algebra textbook out there. So we'll get started in just a moment after we pray, and I've got our lame joke. Father, I thank you for who you are. I thank you for another day of life that you've given to us, and I thank you that we are living and breathing and thinking, and that you give to us the ability to study pre-algebra and to learn it. Father, help us to apply ourselves to the task before us today, and I pray in the name of your Son, Jesus. Amen. Okay, joke for today is a very old one. What do you call a duck that gets all A's in school? Well, he is a wisecracker. You know, wisecracker, well, he's a wisecracker. That's like, what do you call a box of ducks? You know, a box of ducks is a box of quackers. So, anyway, moving right on. Section 4.1 is the integers, and some of you are going to be familiar with this. Some of you, it may be a new concept to you, but more definitions here. We have a set of integers. And what do the integers contain? These have positive integers, negative integers, and zero. Negative integers, and zero. And let me write up here at the beginning, the set of integers consists of positive integers, negative integers, and zero. It's like saying our fruit basket consists of apples, grapes, and bananas. So, apples are a type of fruit, grapes are a type of fruit, bananas are a type of fruit. Positive integers are obviously a type of integers. Negative integers are integers, but also the number 0 is a part of the set of integers. And the way that you indicate a set is by using these braces. And what we're writing here we call set notation. And what set notation is it's a way of identifying all of these different elements that belong together. So it's a way of identifying a group. These little dots here in the beginning, they're called the ellipses, and what that indicates to us is that the pattern that you see demonstrated continues forever in both directions. We see 0, -1, -2, what's going to come next? -3, -4, -5, and so on forever. What do we see happening here? 0, 1, 2, it's increasing by 1, 3, 4, 5, 6, 99 bazillion. So this grouping here indicates what they call the set of integers. You'll notice that we don't have fractions in here. You notice that we don't have decimal numbers. We just have counting numbers, whole numbers, things that whole entire numbers. I'm not saying whole numbers are counting numbers in a technical sense right now, but you see this pattern. And the braces here indicates to us that we are talking about what they call the set of integers. And you can draw a picture on a number line to represent that set of integers. And if you were drawing this number line, you would be using a straight edge, and you would be making these divisions here to be very nice and neat. There's 0 in the center of our number line. 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, and -6. Our number line has arrowheads on the end to indicate that that pattern continues forever in a positive direction, continues forever in a negative direction. So what we have right here in the middle of our number line, obviously, is 0. These numbers here are what they call the negative integers. And the numbers to the right of 0 on the number line, obviously I never learned how to draw braces, doesn't matter how many times I try. These are called the positive integers. And I'm hoping that this is review for you. Let's see. Negative integers, positive integers. Is 0 positive or is it negative? It isn't. 0 is neither positive nor negative. It's just 0. So we have example 1 here. I'm going to keep this number line that I've drawn. I'm going to remove pieces of the information. And we're going to see what they want us to do in our problem. Problem number 1 on example number 1 on page 111 says, write the integers for points A, B, and C on the number line. And here we're just going to say that this one is C and this one is B and this one right here is A. And this is not going to exactly match your book because I made these numbers up randomly. Well, how are we going to determine the number that corresponds to these points? Well, we're going to look at 0 to begin with, and we're going to see that B is 1 unit or 1 space, 2 spaces to the left of 0 on the number line. So they say that B, and they use this colon here. I'm honestly not quite sure why they do that. But B has a value of a -2 because it is 2 units to the left of 0 on the number line. Now we're going to see where we are for C. 1, 2, 3, 4, 5, 6. C is 6 units to the left of 0 on the number line, so it is a -6. Now, what about A? Well, we're not going to the left, but A is 1, 2, 3, 4 units to the right on the number line. So A has a value of +4. Now you saw before, I went ahead and erased those numbers here on the indicating the scale on this number line. Let me go ahead and write them back. I have 1, 2, 3, 4, 5, and 6, -3, -4, -5, and -6. Look at that. C shows up as a -6, B shows up as a -2, and A shows up as a +4. And we got those numbers by seeing how many units to the left of 0 B was, which was 2, how many units to the left of 0 C is, which is 6, how many units to the right of A, of 0 A is, which is 4. You saw that we had negative numbers when they're to the left of 0, and we had a positive value when it was to the right of 0. So that's how this number line is going to work together. Now, with integers, That integer would be read as a positive 4, but we don't put a plus sign in front of it. We don't need it. These integers here are pronounced -2 and a -6. Now, you see where I have my negative signs? They'll teach you in your book to use, to indicate with a raised negative sign that we're talking about a negative integer. That's something that I didn't learn. I find it nearly impossible to make myself write a negative integer with the raised negative sign. You have freedom to do whichever notation works best for you. Now let's go ahead and look at something else I want to show you on this number line, and it has to do with distance from 0. I'm going to make a neater number line here that's not so busy. I'm going to put a 0 in the middle, then I'm going to have a 1, +2, and +3 to the right of 0 on the number line. And then I'm going to have matching numbers to the left. -1, -2, and a -3. Now remember, just a moment ago when we were identifying the points for A, B, and C on the number line, and I said what's the distance from 0? Let's see. If I go 2 units to the left of 0 on the number line, where do I end up? Well, I end up at -2. Now, let's go 2 units to the right of 0 on the number line. 1, 2. 2 units to the right of 0 on the number line is a +2. This is what they're wanting you to notice. Your book here tells us, let's observe that 3 and -3 are located the same distance from 0 on the number line and in opposite direction. Integers like these are called opposites. Every integer has an opposite, and the integer 0 is its own opposite. They're using -3 and +3, but they are the same distance from 0 in opposite directions. We start at 0, so -2 and 2 are opposites. And what do we mean by opposites? This definition here is very important. Opposites are the same distance from 0 on the number line. Same distance from 0 on the number line. So what would the opposite of 3 be? Here's 3. How many units is it from 0? 1, 2, 3. So what is its opposite going to be? If -3 is 3 units to the left of 0, its opposite is going to be 3 units to the right, which obviously is a +3. So a number and its opposite, they look the same except one has a negative sign, one doesn't have a negative sign. Now what about 0? How do you tell how far from 0 0 is? Well, 0, your book will tell you that 0 is its own opposite. It really doesn't have an opposite. So 0 is sort of its own little buddy up here. He sort of plays by himself. So he has a little bit of different rules when it comes to talking about the integers, but he is a part of the integers. Let's go ahead and let me show you something. What about a lot of you are familiar with thermometers. Matter of fact, I'm sure all of you are familiar with thermometers. Now, we live in a part of the country where it doesn't usually get very cold, But our thermometer here that I'm going to draw us a picture of is going to be the thermometer up in a northern state. Maybe Minnesota, but this isn't a good enough thermometer for Minnesota. Here's a picture of my thermometer. Here is 0, so that's 0 degrees. 10 degrees, 20 degrees, 30 degrees. I've got my thermometer broken, meaning that the scale is different. Goes on up to 70, 80, 90, 100. Below 0, we have 10 below. You know, you'll hear weather reports that talks about wind chills that are 45 below 0 in Minnesota, or normal daytime temperatures that can be minus 50 at the North Pole, minus 30. Degrees that are minus are what we took. They represent their negative numbers. So you can think of this thermometer as being a vertical number line that has positive integers, negative integers, and 0. Something else that we want to talk about in this section is called absolute value. Absolute value is very important. Absolute value is the distance from 0. You must learn this. The distance that a number is from 0 on the number line. Our book tells us that the absolute value of an integer tells the number of units the integer is from 0 on the number line. The symbol for absolute value is these straight lines, and consider the examples below. So, absolute value is the distance from 0 on the number line. And a really good example of what absolute value is mileage. Let's say that we start here at the house, and I'm going to drive to Co-op, and that is about 20 miles for me. So I drive my vehicle 20 miles one way to Co-op. Okay, then I turn around, and if this was a number line, you would say that this was sort of positive, right? A positive 20 miles. Now, when I'm done with Co-op, I'm looking for a different colored marker here. When I go home, I turn around and I go in the opposite direction, 20 miles again. Now, if you're thinking about number line going in the left, that's negative. So shouldn't this be a negative 20 miles? So plus 20 minus 20 means that I have driven no miles on the days that I come to Co-op. Is that true? No. Unfortunately, it's not. I drove 20 miles one way, 20 miles the other way. So I drove a total of 40 miles, and that's what they're talking about when they talk about absolute value being distance from 0 on the number line. So here is our number line. Here is my house, which is 0, 20, and a negative 20. It doesn't matter if I'm going to someplace or coming back from it. I am the same distance from 0 on the number line, and those values are positive. This is how they indicate absolute value. They would say that the absolute value, these are vertical bars, absolute value of negative 20. How far, how many units is negative 20 from 0? It's 20 units to the left. but it's 20 units. The absolute value of negative 20 is 20, and the absolute value of positive 20 is also 20 because it is 20 units from 0 in the positive direction. So what you see from this, not only is absolute value the distance from 0 on the number line, but it is always positive. Okay, that's what they have as absolute value. So, if you wanted to have some questions here regarding absolute value, example 2 says write the absolute value of each. Example 2. 2a says what's the absolute value of a negative 9? Part B says what is the absolute value of 0? And part C, what is the absolute value of 4? Absolute value is always positive. So negative 9 has an absolute value of negative 9 is a positive 9 because it's 9 units from 0. Absolute value of 0, we said 0 was its own opposite. It's that one little weird case. Absolute value of 0 is 0. The absolute value of 4 is 4 because 4 is 4 units to the right of 0 on the number line. So absolute value is always going to be positive, or it's going to be 0 if you're finding the absolute value of 0. Now we have one more thing that we want to do in this section. It says you can compare positive and negative integers using the inequality symbols less than and greater than. This is less than. This is the symbol for greater than. If you're still being confused with those, I need you to get unconfused because we use less than and greater than all of the time. So if we have this number line once again, let's do -2, -1, 0, 1, and 2. And we're going to compare two numbers. We're going to compare a -2 and 0. And we want to know, is -2 greater than 0? Or is -2 less than 0? Now in real life, would you rather have no money in your pocket, or would you rather owe mom and dad $2? Well, it's much worse to owe somebody $2 than to have no money, okay? So what you see here is that -2 is less than 0. The way that will help you determine what number is less than the other when you have negative numbers is the number farther to the left on the number line is the smaller number. Left on the number line is the smaller number. Okay, so if you have a -17 and a -15, which number is going to be further to the left on the number line? -17. So -17 is smaller than a -15. Or -17 is less than a -15. And one thing that you can do to help you remember which way these inequality symbols are going is you put the point facing the smaller number. The point here faces this -2 because it's smaller. The point faces the -17 because it is smaller. the point faces the 2 because it's the smaller number. Negative 2 is less than 0. Negative 17 is less than negative 15. 5 is greater than 2. The point is pointed toward the smaller number always. That will help you with your greater than and less than symbols. Now, this last example that I want to say says, write the integers in order from least to greatest. Use greater than or less than. So they want us to order these numbers, -1, 3, and a -5. Now think of your number line. Which number is going to be furthest to the left? It's going to be -5 is less than, which one comes next? -1, which is less than a +3. So we have ordered these numbers from least to greatest using our inequality symbols. And that's what you're going to be working with on your homework for section 4.1. Okay, now to my kids who are in my pre-algebra class in our local homeschool co-op, there are 2 videos from Algebra 1, it's section 1.1 and 1.2, where we talk about integers and opposites and absolute value at greater detail, coming at it a little bit differently. Please feel free to go ahead and access those or send me a text asking for that link if you need some help with this section. Thanks, and I'll see you next time.